All right, hello again, everyone. Welcome. Today we're going to talk about the looping constructs, which are while, do while, and for. This is going to be a bit longer video than the other ones that I've posted, so you might want to press pause and go get yourself a beverage. It'll still be shorter than a regular lecture, but it'll be longer than the other videos. Anyway, last week, assuming you were watching this during week 4, we talked about control flow and we introduced the if statement to let your program potentially do a variety of different things at runtime. Today we're going to introduce another set of ways to change the control flow of your program, and these are the iteration or looping constructs. Iteration is the fancy word for looping. We'll use both more or less interchangeably. So, when we talked about control flow, we talked about different kinds of algorithms that were not possible without having an if statement. There are also different kinds of algorithms that are not possible to implement without having some kind of iteration construct. So sometimes you want to let the user decide how many times something happens. So for example, your program lets the user type in a list of numbers of arbitrary length and then computes the average. Sometimes you want to do different for every element in an array. Again, we haven't talked about arrays yet, but an array is basically a set of numbers, or a set of things, a vector, if you will. So it can compute the difference from the average for a list of numbers. Sometimes you want to do something exactly a certain number of times, and you don't want to just rewrite the same code for every time. You don't want to have 10 copies of generate random number. You want to say, I want to generate 10 random numbers. So these are all things that are enabled by the looping constructs. So these are the statements that we have. They change the control flow of a program. C provides 3 different iteration statements. Those are while, do while, and for. And we're going to discuss each of these one at a time. So the simplest one is while, so that's where we're going to start. And what it looks like is while, parentheses, expression, close parentheses, braces, series of statements, close brace. Okay? The expression here is called the controlling expression, or the loop test. And much like the if statement, expression is treated as a logical value, that is, a true or a false value. So if expression evaluates to 0, it's false, and if it evaluates to anything else, it's true. And if expression is true, the statements block is run. If expression is false, the statements get skipped over. So far, it looks just like an if. The only difference is that we've replaced if with while. The difference is that it repeats the statement block. So this gives you the ability to create control flow patterns like we talked about earlier in this video. So where if this while were an if, it would just either do these statements once or not at all. With a while, it does the number of statements any number of times, from 0 to infinity. And we're going to see all those cases in some examples. So here's how it works. When the compiler sees a while statement, it checks to see if the expression is true. If it's false, it skips the statement block, just like in an if it's false, and goes to the next line of code. If it's true, then it runs the statements block. It does the code in the statements block. Then, at the end, it checks expression again. If it's false, it skips over the statements block to the next line of code. If it's still true, it runs the statement block again. Then it checks expression again. If it's false, it skips the statement block and goes to the next line of code. If it's true, it runs it again. And this continues forever until expression is false, whichever happens first. So we have a flowchart of that, just like we had a flowchart for the if statements and the if-else statements. So while expression statement looks like this. So we start at start, we come down to the diamond, the decision point. If it's false, we skip over statement and go on to the next line of code. If it's true, we go back to start, back to the test, evaluate the test again. If it's true again, we go back again. If it's false, we exit. So as long as the expression stays true, we keep going, we keep iterating, we keep looping, right? Because there's a loop in this flowchart. Note that this arrow goes upward, right? So now we're able to go backwards in our programs. We're not just skipping. Before we had the ability to skip. Now we have the ability to repeat. So here's a real simple example that I wrote. It just has I equals 0, one integer value, and while I is less than 5, we print I is %d I. We print out the value of I, and then we do I++, we close the brace, we return 0, we end the program. What this prints out is I is 0, I is 1, I is 2, I is 3, I is 4. Okay? I is initialized to be 0. We get to the while statement. We see I less than 5. Is I less than 5? I is 0, so yes. We call printf with the value of I, which is 0. We add 1 to I and store the result back in I, right? That's what the increment operator does. It increases the value of I by 1. So we add 1 to I and store the result back in I, so I is now 1. Because it's a while loop, we do I is less than 5 again. Is I less than 5? I is 1, so yes. We print the current value of I with printf. We increment I, so it was 1, now it's 2. Is 2 less than 5? Yes. Print out the value of I. Increment the value of I to 3. Is 3 less than 5? Yes. Print the current value of I with printf. It's 3. Increase I. Add 1 to I and store the result back in I. I is now 4. Is 4 less than 5? Yes. Print 4. Add 1 to I and store the result back in I. I is now 5. So we come back. Is I less than 5? Is 5 less than 5? No. That's false. So now we skip the statements block. Execute the next command, which happens to be return 0, and ends the program. Okay? That's why we get I is 0, I is 1, I is 2, I is 3, I is 4. And we don't get I is 5. Okay? Make sure your loop test changes. Your controlling expression. In this case, it's I is less than 5. Our loop test depends on the value of I, and the value of I changes every time you execute the loop body. As a result, the loop test will also change. Make sure that you do this. This is really important. If your loop test never changes, you'll never exit the loop, right? So here's an example of how not to do it. I have the same program as last time. The only difference is I've taken out the I++. And so what happens now is we get I equals 0 until the end of time or until your computer melts down, right? And the reason for that is that I forgot to put I++ into the loop body. So I never changes. So the value of I is less than 5. The value of the controlling statement never changes. So we have what is called an infinite loop. Here's how you terminate infinite loops in Unix. You will make this mistake at some point if you program for long. I actually wrote myself into an infinite loop while I was preparing this lecture, so don't be ashamed of it. Or I should be ashamed of it, but I'm not. It's not a big deal. To terminate it in Unix, hit Control-C. The Controls key and the C key at the same time, and it will terminate your program. Then go fix your infinite loop so you don't have that problem again. Okay? Here's another example of a while loop, we initialize I to 1. We say while I is less than 20, print out the value of I, and I times equals 2. So if you remember from the lecture where we talked about logical operators and bitwise operators and the compound assignment operators, this means take the value of I, multiply it by 2, store the value back in I. So the first time through the loop, we have I is 1. Is I less than 20? Yes. Print out 1. Multiply I by 2. So I is now equal to 2. Is 2 less than 20? Yes. Print out 2. Multiply I by 2. So now it's 4. Is 4 less than 20? Yes. Print I is equal to 4. Multiply it by 2. So it's now 8. Is 8 less than 20? Yes. So I is 8. Times equal 2. I is 16. Is 16 less than 20? Yes. Print I is 16. Multiply by 2. I is now 32. Is 32 less than 20? No. So we end. We go to return 0. We end the program. We don't see I is 32. So this is just an example to show that you don't have to use I++, right? Anything that changes I, changes your loop test every time through, can be fine, right? So for each iteration, your loop test should change. In this case, we're doing it by using the times equals compound assignment operator. And note also that while loops can happen 0 times. So the expression, the decision point, comes before the statement, right? So if the loop test is false the first time it gets there, statement is never executed. We skip over it entirely. What if we don't want a loop to be skipped, right? There are a lot of times where you want to be sure that the loop body gets executed at least once. So for example, you're taking input from a user until they put in a special value that says that they're done, right? We'll see an example of that. But that's what do while is for, right? So that looks like do braces sequence of statements, close brace, while expression, right? So we have a do at the top, a while at the bottom, while expression at the end, okay? Note the closing semicolon. While doesn't need one, but do while does, right? So when you're using do while, make sure you put a semicolon at the end of it. This is what do while looks like as a flowchart. So we start, we do the statement first, then we get to the decision point. If it's false, we go on to the next line of code. If it's true, we go back to start, we execute statement again. So for do while, we can do exactly the same thing we did with while. Here we print out I, the values of I from 0 to 4. So I is initialized to be 0. We print the current value of I. We increase I. We see if I is less than 5. It is. We do it again. We do it again. We do it again. We do it again. We exit. So far all we've demonstrated is that while and do while can accomplish the same thing, which is fine. It's not that interesting, but it's a good thing. It's good to know that you can use whiles and do whiles. You can use either one, whichever is more appropriate. But let's look at an example where do while and while would perform differently. So here's another do while example. So I've initialized two integers, number and sum. I've initialized sum to 0. And I'm reading in number with a scanf. And every time through, I'm adding sum to number while number is not equal to 0. The user can enter 0 to quit, right? So I get the sum of the number, and then at the end I print out the sum of the numbers and I return. Okay? So I want the user to tell me how many numbers he or she or they is typing in, right? So here's a snippet of that code where we have just the do while loop. So we say enter an integer, 0 to quit, 1. Okay? 1 is not equal to 0. So we loop. Enter an integer, 2. Add 2 to sum. Is 2 equal to 0? No. So we loop. Enter an integer, 3. Add 3 to sum. Is 3 equal to 0? No. So we loop. Enter an integer, 4. Add 4 to sum. Is 4 equal to 0? No. So we loop. Enter 5. Is 5 equal to 0? No. So we loop. Enter 0. Add 0 to sum. Sum doesn't change. Check if number is equal to 0. It is. So this loop statement is now false. Number is equal to 0. So we exit the loop, we print out the sum, and the program ends. So in this case, we add 1 plus 2 plus 3 plus 4 plus 5 plus 0, get the sum equal to 15. We can also just immediately enter 0 and quit, right? But the user needs to be able to enter input at least once. We don't know in advance how many times this loop needs to run. The user is telling us how many times this loop is going to run. So it needs to get in here at least once, which is exactly what do while is good for. Example 2 would be a real pain to do without do while, if you had to do that with just while. Once we cover a bit more material, you can do it yourself to prove it, if you're so inclined. But for now, just take my word for it. So anytime a loop needs to run at least once, it needs to do some initialization or some cleanup, you should use do while instead of while. Okay? So that's while, do while. Now we're moving on to for. So the third iteration statement that C provides is the for loop. So we've already got while that tests the condition before the loop, and do while that can test the condition after the loop. What's special about for? In some ways, there's nothing special about it. It works just like while. But it is both clearer and simpler, so it's usually preferred. If you see other people's code, it will more often have fors in it than whiles. Okay? So what for looks like is 3 expressions in parentheses separated by semicolon followed by a statements block. Okay, so we have for expression 1, semicolon, expression 2, semicolon, expression 3, then a statements block. This is actually the same code as if we had done this. Expression 1 first, then while expression 2, and then expression 3 at the end of the statements block. These two accomplish the same thing. So expression 1 is the setup. It happens before the loop test, before we even get to the loop, right? Expression 2 is the loop test, right? It tells us, do we go into the loop? And then expression 3 is usually what changes the loop test, right? That happens. So expression 1 gets executed immediately before the loop. This is most often used to initialize the value of your loop test variable. Expression 2 is the loop test, and expression 3 occurs after the loop body, but before the end of the loop. So usually you would use this to update the value of your loop test variable. So you initialize your variable, test your variable, update your variable. That's expression 1, expression 2, expression 3. Okay? This is what the for loop looks like as a flowchart. It's a little bit more complicated, but that's just because we need to have expression 1, expression 2, expression 3. You can see that it looks just like while, except for, expression 1 at the beginning and expression 3 at the end. Okay? I promised that it would be simpler and clearer. but we haven't seen it yet. So why should you believe me that it's true? Because I'm going to show you. We're going to see an example in just a minute. We're going to do the same example we did for while and do while, where we print out the numbers from 0 to 1 to 5, or from 0 to 4, really. Right? So here we have int I, for I equals 0, semicolon, I is less than 5, semicolon, I plus plus, printf, I is %d. Okay? This brings all the loop stuff into the loop statement itself. I don't have to do I equals 0 beforehand. I don't have to put I plus plus in the loop body. Everything related to the loop is in this one statement. Then the loop body is just the stuff you do each time through the loop. Okay? So it's much less likely that you'll forget part of it. We saw that it's very easy to make an infinite loop with while. You can just forget to update the loop test variable. For requires 3 expressions and won't compile otherwise. So it's hard to just blank and forget to do part of it. And also it's self-documenting. So with while, if you have a big program, you can have your while statement here. You can initialize it way up here. You can update your loop test way down here somewhere. And you can't necessarily even see all of them at once. It makes it harder to track what's going on in your loop. With for, it puts all the bits right here. Everything you need to know about this loop is in this one line. Okay, that's really helpful and it's really powerful. So we've explored the 3 types of loops. We've seen while, do while, and for. I'm gonna talk a second about nested loops, which isn't really a separate topic, but it's a relatively common pattern in programming, so you will see it at some point, including in this subject. Maybe you want to iterate over the rows and columns of a matrix or of an image, or you want to do something for a series of x and y values. So you can put loops inside of loops. So we have a nested for here. So I've declared 2 variables, 2 integers, I and j. And for I equals 1, I is less than or equal to 5, I plus plus. And then the loop body of I is another loop. For j equals 1, j is less than or equal to 5, j plus plus. And then I print out all those values. So %d times %d equals %d. So I times j equals I times j. And I print that out each time through the loop. Okay? And this is what we get. We get 1 times 1 equals 1, 1 times 2 equals 2, 1 times 3 equals 3, 1 times 4 equals 4, 1 times 5 equals 5. 2 times 1 equals 1, 2 times 2 equals 4, 2 times 3 equals 6, 2 times 4 equals 8, 2 times 5 equals 10. 3 times 1 equals 3, 3 times 2 equals 6, 3 times 3 equals 9, 3 times 4 equals 12, 3 times 5 equals 15, etc. So notice that I, the first value, is changing more slowly than j, the inner loop, right? So what happens is, for I equals 1, we do the loop body. The loop body is run this whole second loop. So for I equals 1, j equals 1, j equals 2, j equals 3, j equals 4, j equals 5. We get to the end, we do I plus plus, now I becomes 2. J equals 1, j equals 2, j equals 3, j equals 4, j equals 5. We get to the end of the loop, we do I plus plus, I equals 3, j equals 1, j equals 2, j equals 3, j equals 4, j equals 5, etc. So for every single iteration of the outer loop, you run the inner loop a bunch of times. In this case, 5 times. So that's generally going to be the case when you see nested loops. The outer loop is the slower loop. The I loop here is the slow loop. The j loop here is the fast loop. So for every one time you go through I, you go through j 5 times. Okay, so just be aware of that with nested loops. So to recap this video, sometimes you need to do a bit of code a bunch of times. And in order to do that, C provides the iteration statements, which are while, do while, and for. Look out for infinite loops. That's not a huge problem most of the time if you're using for, but if you're using while or do while, you need to be careful. You need to make sure that you're updating your loop test every iteration. And just be aware of nested loops. You're not going to need them right away. They're not in assignment 1, but you will need them before the semester is over. So be aware that you can have loops inside of loops inside of loops in order to work over multiple dimensions of data. Okay? That's it for now. Thank you. Be well. I'll see you next time.